Hello, everybody. My name is Aswath, and I'm from India. And I'm recording this video as part of the Capstone project in the Advanced Machine Learning and Data Science course offered by IBM in association with Coursera. So, as part of this, I have picked up a use case which is about predicting a bankruptcy of a company. Now, I have some experience in the field of data science and machine learning, and this course really attracted me to upgrade myself in the same field and call myself a specialist. So as part of that, I have built a use case, which, as I said, is bankruptcy prediction of any company. And I have picked this use case from Kaggle and also the dataset from Kaggle itself. Now, as part of that, we'll be given up with a data set which will have various numeric and other fields, and we'll have to predict whether a given company might go bankrupt or not. I'm sharing my screen to further explain what I have done. I'll take you through the Kaggle notebook that I have used and also the architectural design document that I have prepared as part of this. Now, as you can see, this is a Kaggle home screen of mine, and I have opened up the notebook, which clearly shows what all has been done as part of this use case. Now, to explore the data set initially, we already have the data available in Kaggle. We just have to import it, and I also import the various required modules as part of this. And when I load the data and see, I could clearly understand that most of these fields, almost all of these fields are numeric and in fact decimal values ranging from 0 to 1. And there are various set of rows and columns which help us predict the final output. Now we also have some categorical variables which we'll see later on down the line. Now, as usual, to start with some basic analysis of the data set, like how many rows it has, how many columns, data types of various fields, and some basic statistics. As the first step, we can see that we have almost around 7,000 rows, which is exactly 6,800 rows. And there are many columns in it too. And when you see the data type, everything is almost integers here, and when I check the info of each and every column, we can see that all of the columns are non-null ones, and we have various column values like if you see from the top, we have some values which help us associate a company being bankrupt or not, like ROA before interest and depreciation before interest percentage, gross margin, sales gross margin, operating profit rate, then some kind of tax calculation, and the cash flow rate, tax rate, revenue per share, operating profit growth rate, net value rate, quick ratio, etc. So these are all terms for in terms of a company's economy. And moving to next step, we try to understand in terms of the basic statistics of the data set which we are using. So as I said, the count is around 6,800 rows, and almost all of the columns have proper values, and we don't see any empty values or missing values as such. And the mean of the individual columns ranges from somewhere around 0.5 up till even as low as 0.01, etc. So this is all about the description, and we also have the 25%, 50%, 75% quantile. And so to start with, I'm taking a look into the final output column, which we are going to predict the bankrupt column, whether it is a company is bankrupt or not. I'm seeing that majority of the companies have been given a flag or a target label as not being bankrupt, and only a few are bankrupt. So 0 indicates no bankrupt and 1 indicates bankrupt. So this distribution of data set is too much skewed towards the company not being a bankrupt. Hence, there is a high chance that the model easily predicts a given company as not bankrupt, even though they might potentially be bankrupt. So that happens when we usually have heavy skewness towards one class of data than the other. Now, what I do straight away is I try to identify what are all the categorical variables or the fields which have categorical values in them, and pick them as into a list called as categorical, and the rest of them all as numerical, because we don't have any other character or any other type of field in the dataset which we saw earlier in the info tab. Now, so there are total 94 numerical values, numerical fields, and 2 categorical fields, and a target label, which is bankrupt. Now I'm just plotting each and every numerical field against the label to see the distribution of each and every field for the values of bankrupt 0 and bankrupt 1, just to see how the data varies or is similar when we compare each and every field with respect to the final target output. Now if you see in this particular feature, the values for bankrupt companies not being bankrupt, we can see that it's distributed much more than for those which fall under the bankrupt uh, flag. Now this kind of analysis helps us understand and identify pattern of data set with respect to each and every feature, and based on that we can make decisions saying that, well, for target flag 1 the data is distributed like this, so if the test data set has a value ranging between this to this, we might potentially end up predicting a 1 there, and vice versa for 0, right? So almost all of these fields I have analyzed and come up with a distribution, but most of the cases we can see that the distribution of various features are similar in case of both 0 and 1. Hence we cannot really conclude based on these data values as directly as whether they are 0 or a 1, right? For example, here we can see that most of the data values are 0, nearby 0, but it is also spread along till 1, whereas for bankrupt equal to 1, only 0 values exist, 1 or 2 other values as well, right? So these kind of fields can help us directly predict, or this can become a more important feature than other, because it has clear disassociation for both the flag values. Now I have done a similar analysis for almost all of the numerical fields, almost 94 of them, and can see that the distribution is not much different for many fields, right? So moving on, what I have then done is tried plotting the categorical variables to find out how the distribution of data is for these this flags for bankrupt 0 and 1. So if you see here, uh, for liability assets flag, the most of the values are 0 when the bankrupt flag itself is 0, and only a few values are 1. Whereas for bankrupt equal to 1, there doesn't exist any liability assets flag, right? Now, moving on. Now, net income flag is much more for 0, whereas for 1, it is very less. Now, this kind of analysis also helps us directly correlate a field. Now, I have just plotted a Pearson correlation matrix for various fields to find out what kind of correlation exists between each and every feature with respect to the bankrupt flag. And moving on, I am then picking up all the features. Since there are no missing values as such, I thought we should directly be using the columns as features. So I have just picked up all the features together and then gone for train, test, split, and prediction. Now, what I've also done here is I have used a validation set, which I have derived from the test set itself after using the features and label and splitting it using train, test, split function. I've got the train and test set, and I have again used this test set to split further to obtain the validation set. Now, so this is how the final data set is split up, right? Now, what I have done then is I have tried various models, starting from logistic regression till the ensemble methods, to see what kind of accuracy, efficiency, precision, and recall, F1 score, etc., are obtained for all the models, and finally chosen one which might be potentially helpful for us to identify the correct bankrupt company. Now, for logistic regression, you can, as we can see that the predictions, even though the accuracy is high, the predictions in terms of false positives and false positives and false negatives is higher. So in such cases where we are trying to predict bankrupt companies, which is really important, we really cannot afford to miss any potential company as bankrupt, right? So we might give a false positive saying that if a company is not bankrupt, it's okay to say that it is to some extent, but we really cannot afford a potential bankrupt company, to say in our model, which might say that it's not a bankrupt company. So in such cases, we need to be very careful, and we need to reduce this false negatives as much as possible. So by keeping this in mind, I have tried a few other models as well to understand how much the false negatives are getting reduced. Random forest doesn't reduce many. The SVM classifier does reduce it to 0, whereas we do not see much of these values. So I've then again gone ahead and tried other model in the ensemble method, like gradient boost and XG boost. Gradient boost also gives 9 false negatives, and Canon gives 3 of them, and XG boost gives 8. Now, after doing a careful analysis of which model we can finally choose, I came into a conclusion that the K neighbors classifier is the best option here, because it has minimum of false negatives and has equally balanced the other categories as well, right? Now, so finally, based on this, I have concluded that the K&N classifier is the best model which you can use with least false negatives and clearly identify the potential bankrupts as much as possible. Now, I would like to take you through the architecture design document. Just give me a moment. Now, uh, this is my final architectural design document, where I have justified each and every step that I have followed in my use case. Right? If you see here, all right, so this is my architectural design document. So if you see here, I have tried to explain the company bankruptcy prediction use case as to what steps I have performed and why I have performed. So starting from the data quality assessment step, where I've clearly mentioned that almost all of the data sets are numeric, and we do not have much of the empty spaces and missing values and inconsistencies around. So overall, the data appears fine, and it has almost no issues with quality. Then I have gone with the exploratory data analysis, where I have tried to analyze the numerical and categorical variables, and I have explained the distribution of each and every data point with respect to the final flag of bankrupt or not. And I've also checked the categorical variables in the same manner. Now, this I have just pasted the Pearson correlation matrix that I have plotted, the heat map, and then I've explained what kind of feature engineering I have done and what kind of ML algorithm I have chosen. Now, I have used almost all of the columns as features for training and testing data sets, and I've seen, you know, after multiple iterations, I understood that the final and the best model will be K-NN classifier, because it has the least number of false negatives. And in case of use cases like bankruptcy predictions, where we cannot afford to miss any potential bankrupt company, it's best to go with the model which has least false negatives. Now, performance evaluation I have done using precision recall and F1 score, which I've shown in my notebook, and a combination of all these evaluation metrics, which clearly show, because the main reason why we have to go with all the three measures is because of the high skewness of the dataset towards the final target. right? Hence, when we see a skewed data set like this, it's always best to use multiple measures to analyze and come up with a conclusion as to which model we can use. So that's pretty much it from my end. I hope we all are happy and satisfied with the way I have, you know, gone ahead with this use case and come up with the final predictions and built a fantastic model that gives least number of false negatives. Being that in my focus, I built this. So please evaluate and let me know what you think. Thank you so much. Bye.